Okay, so now I'm going to show you how you can solve an exact differential equation. Now, as we said before, you need to first prove that this differential equation is exact. So, what you need to do is to identify your m, which is the term associated with the x, and to identify your n, which is the term associated with dy. Now, you need to say that m equals 2xy and n equals x squared minus 1. Then you need to find that dm over dy. You're going to differentiate this with respect to y, so it's basically 2x. And here you will have dn over dx. So if you differentiate this with respect to x, you will get 2x. Now, because these two are together, are the same, the differential equation is going to be always exact if dm over dy equals dn over dx. Okay, so now your next step is to solve this differential equation. Now, what you need to do, the first step you need to do is to say that I will have df divided by dx, and I will set this to be equal to m, and I will have df divided by dy, and I will set this equal to n. Okay, so we can start either way. You can start with this expression or you can start with this expression. Now I'm going to start with the left one, which is df over dx equals m. Now you can rewrite this as df equals m times dx, right? df is basically a function in terms of x and y, and m we found m to be 2xy, I think. Yes, it's 2xy. So we have 2xy times dx. Now, what you need to do is you need to integrate to find an expression with a constant c. So you will have f of x and y equals the integral of 2xy dx. Now, because we're integrating with respect to x, this means that the 2 and the y are constants, so you can drag them out of the integral. So you would say 2y integral x dx, and this is basically equal to 2y times x squared divided by 2 plus c in terms of y, because we integrated with respect to x, and this is a function of x and y, so this is going to be in terms of y. Now you can see that these two will cancel, and you will end up with f of x and y equals yx squared plus c in terms of y. Now our goal is to find this c in terms of y, so you can find the general solution. Okay, so let's now try to make this box. Yes, so we need now to find C in terms of Y. Now how do we do that? We started at first with this one, right? So now we're going to use the second expression, which is df over dy equals n. df over dy equals n. So you're going to say df over dy equals n. Now df over dy means this function, you're going to derive it with respect to y. And you're going to set that to be equal to n. So let's derive this with respect to y. We have, let's just erase this. Okay, we need now to differentiate this with respect to y. So what we're going to get is x squared. Now we are deriving with respect to y, so x is a constant, plus c prime in terms of y, and you're going to set this to be equal to n. But what is n? Well, now n again is x squared minus 1. So again we're going to say this is x squared plus c prime in terms of y, and this equals to x squared minus 1. Now you can say that these two will cancel obviously, and you'll have c prime in terms of y equals minus 1. But now, as you can see in our differential equation, our solution, basically this one, we were having c in terms of y. But now, what we're having now is c prime in terms of y. So we need c of y. So simply you're going to integrate both sides with respect to y. So the integral of c prime with respect to y is basically c of y, and the integral of minus 1 with respect to y is minus y. So this is your c of y. That's definitely not a y. Okay, now your last step is to replace this c in terms of y in your solution, which is the yellow box we just made. So instead of c in terms of y, I'm going to replace this with the expression we just found, which is minus y. So f of x and y equals y x squared plus c of y. So f of x and y equals x squared y plus c in terms of y, which is this expression, so it's minus y, and this is your final solution.